Okay, so we're going to talk about EV selection and review the many EV choices that you now have. A few years ago, there were only a couple of EV choices, Nissan Leaf and Tesla, expensive Teslas, Model S's and X's and so forth. Now there's quite a number of cars in most of the categories, crossovers, sedans, SUVs. There's one pickup available now and soon to be a few more. So there's lots of choices. And we'll look at those and we'll actually, I have pictures of most of the cars that I'm talking about. So then the second half is really the greatest revolution in autos since the Model T. That may sound like I'm overstating what's going on, but I don't believe I am, and you can judge for yourself after I tell you why. And then I'll talk about the 21st century auto and auto manufacturer, because I think it's going to be quite different than what we're used to from the last century. Okay, so there's 5 key questions before you go buy an electric car. One is, can I plug the car in where I live? If the answer is no, then you'll lose kind of a major advantage of having an EV. And that advantage is it's always ready to go and it's always charged. And you've charged it very cheaply and you don't have to do anything extra to charge it. You don't have to go anywhere to essentially refuel the car. You can still, operate an EV if you don't have a home way to charge it where you live, but it's not as convenient. You can charge them at shopping centers and at some restaurants, and you can charge them at high-speed charging superchargers and the similar ones from other manufacturers. So you can do that, but it's not nearly as nice. So the second question is how many miles you drive a day. As I mentioned on Tuesday, most of the drivers in the United States drive less than 100 miles per day. And that covers 99% of all US drivers. So if you're doing less than 100 miles a day, then almost any EV that is on the market today will work. And then, do you want to take long trips? The answer is yes. Then you really want an EV with a range of at least 250 miles. And in my view, it's better if it's over 300 miles because there still aren't enough fast charging stations in the United States to allow you to go literally anywhere in the country with an EV, especially if the range is below 300. So that's important. But if you don't want to go on long trips, let's say you have a SUV or a minivan or something that you use for travel, then almost any EV will work if you're basically going to use it as a metropolitan area car. And then the fourth question is kind of a strange one for buying a new car, and that's how comfortable am I with change and new technology? So there are a lot of things that are different about EVs, and they drive differently. The controls and the interior may be much more computer-like than existing cars. And all of these things take a few weeks to kind of relearn. I mean, it's kind of the same things that you're doing in an ICE car, but you do them in a different way. And then the fifth question is, do I need my next car to drive itself, let's say due to age or medical conditions or something? And if the answer to that question is yes, then Tesla is really your only choice because they're the only car manufacturer that's really taking on the challenge of being providing a self-driving car that can literally drive anywhere, including places it's never been before. So there's kind of two ways to do self-driving. One is to have super detailed maps and have the car drive in on all of the streets that in a particular small area, usually not even the size of a city, and then the car can drive itself in that restricted area. But Tesla is not taking that, making that choice in their self-driving. They're trying for the full capability to drive anywhere a human can drive. Okay, so there's also some criteria you could think of for EV selection, some of which are similar to buying any car, like do I have enough money to afford this car? So I won't talk about those. But first, you need to decide if it's mostly an urban car or if you want to take long trips. Cars are expensive, so in my view, I wanted a car that I could use everywhere. And then pick the type of vehicle, and then you can use these criteria. So the range, as I mentioned, needs to be over 250 miles. If it's only an urban car, then 200 is fine. You need to like the looks of the car. I mean, it's something you see every day. So this is, I guess, the same as a nice car, but you want to, when you walk out to the parking lot, you want to say, wow, that's a nice looking car. Efficiency. So just like the miles per gallon on an ICE car, it's better if you have a car that can travel more miles per kilowatt hour. They're cheaper to operate. They're lighter than a car that's not efficient, and it's faster to charge. If you have a 100 kilowatt hour battery, it'll take longer to charge it than if you have a 75 kilowatt hour battery. Features, especially those features that affect comfort, ease of use, and joy of driving. So quite a few of the EVs on the market today are fairly high-end cars. They're kind of luxury brands. And so that means that a lot of them have a lot of comfort features and a lot of features that you don't find in every car. So assistance in driving long trips. Even ICE cars now, a lot of them will do lane keeping and traffic aware cruise control, where they slow down if you come up behind a truck and so forth. And even those two pretty straightforward features make a big difference in how easy it is to take a long trip and how rested you feel after you've driven all day. Safety. The only reason I put it this low is that most EVs have fairly good safety scores. And that has to do with the configuration of the car with the battery at the bottom. I mentioned that it's difficult to make those cars roll over. It also provides a very strong body structure so that if it gets hit from the side, it can't crush that battery case underneath the car. So they tend to have high scores, but you still need to check it because there is quite a difference. I mean, not all EVs are 5-star rated on all the safety events. So ease of interacting with service and the recommended service frequency. So one of the big advantages of an EV is that you don't have to take it in for service to get the oil change and the air filter change and all those kinds of things. But some of the manufacturers are recommending like 1-year service intervals, and you got to realize that's for their advantage, not yours, because it doesn't really need service every year. If it needs service every year, then it's not a well-designed car. Okay, so let's look at the choices. So sedans. I got this from a website, plugstar.com. And it's really, really nicely made with filters in the left column that you can select the kind of cars you're looking for. You can set price range. You can set how far it travels. You can say whether you want a plug-in hybrid or just a battery. Look at the battery hybrid or battery vehicles, and so it's really handy. And they put the key information on each one of these little tombstones, and the name of the car, the price, and the yellow bar is kind of a bar graph of how far it'll travel on a single charge. So it's got the key information, and then if you click the more, it'll give you more detailed information on each of these cars. So it does give you each type of car, and so a lot of these have different models. So the Polestar, for example, has a single motor and a dual motor. Similarly, the Tesla Model 3 has a single motor, which is its standard here, and an all-wheel drive version, long range, which is the one I have, or a performance all-wheel drive. And of course, those are all at increasing prices. Then Audi Sportback. So now we're getting up into the $60,000 range. And then we move to the Porsche Taycan, which is a very cool looking car, $75,000 base price though. And then a performance one that starts at $80,000. And Audi e-tron GT is their, they have kind of an e-tron family, and the GT is the sedan. And then for full-size sedans, we have a Tesla Model S, and the Model S Plaid is their performance Tesla, so it's very expensive, $130,000. And then at the top end is a Lucid Air Dream edition, and that's a very nice looking car, and it's kind of, I think, going to set the new standard for what the kind of most expensive electric sedan is. Okay, let's take a quick look at each of these. And I'll just do it, I won't show you the single motor, dual motor version because they look the same. So this is the Polestar. It's made by Volvo. So it's a pretty good looking car. There's a Tesla Model 3, which I showed you yesterday. There's an Audi e-tron. So it's interesting to me, some of the legacy manufacturers, they really like grills. And you don't really have to have a grill in an electric car because it's not wasting 80% of the energy it's using as heat. So you don't need a grill to cool it down. But they must like the looks of a grill. So they put grills even on their electric cars. And then the Porsche Taycan 4S, which is, I think, a really sport, it really looks like a sport car, but it is a four-door sedan, and it'll seat 5, so it's a real sedan, but it looks like a sports car and drives like a sports car too. And the Tesla Model S is a full-size sedan. And then here's the Lucid Air Grand Touring, and so it's really a nice looking car. Okay, so let's move to hatchbacks. There's only 4 of those, and including the original, from like 2012, I think was the first Nissan Leaf, and it's very low cost. It's under $20,000. So if you want a car for travel in a city, this is a good choice. You could buy it cheaply, and it has a 150-mile range essentially, so it'll work for a city, and work for 70. If you only drive 70 miles or less, or 50 miles or less, then it will work. But it is fairly cheaply made, and the interior looks pretty cheap. Then there's the Mini Cooper, and it's only a 2-door, but it's kind of a cool looking car, and there's lots of room in it because it's kind of a tall square car. And then Leaf Plus gives you 226 miles range, so that gets you in the range that you could drive it on longer trips. And then there's a Chevy Bolt to 259 mile range. So all of these are, $31,000 or below. All right, take a look at these. Here's the Mini Cooper. Kind of interesting that they, they paint a couple of things yellow, so it kind of stands out. And then I didn't show you the Nissan Leaf because I wanted to show you the Nissan Leaf Plus. So again, it kind of looks like a regular gasoline-powered car with a grill. And then there's the Chevy Bolt. Unfortunately, you can't buy a Chevy Bolt right now because, as I mentioned on Tuesday, they're in the process of replacing all the batteries of the boats they've already sold. So they have no batteries to build new cars. So now in the crossover group, excuse me just a second. Okay, in the crossover group, we have a Mazda MX-30. So again, we're starting at fairly low cost. And Hyundai Kona Electric, 24,000. Kia Niro is about 30,000. Volkswagen ID4 is 30,000, and a Bolt is 30,000. And the Ford Mustang Mach-E is a little bit more. Although, don't be fooled by these prices. These are the list prices, and many Ford dealers are charging $20,000 over their list price. So just because they can. Another irritating thing about dealers. So then there's another set of these. Different versions of the Ford Mustang Mach-E, and Audi Q4 Sportback is a crossover, and a Volvo XC40. So you notice, all of these have over 200 miles range except for the Mazda. So there's lots of versions of the Mach-E. And then there's the Tesla Model Y, long-range all-wheel drive. And the reason there's really multi-models of the Model Y, just like the Model 3. But right now, they're only selling the long-range all-wheel drive. And it's because they can't make enough of them. So they want to sell the $57,000 cars until they satisfy that market. And then the Audi e-tron is about the same price. So let's take a look at these. So there's the Mazda. At least they made the grille really small. Not bad looking. Here's the Kona, Hyundai Kona Electric. Notice its charging port is in kind of front bumper. Strange place to put it. Almost everybody else puts it either left in front of the driver or in the rear quarter panel. Kia Niro. So they have kind of a fake grill. See, it's a solid grill. It doesn't really have air holes, but it still kind of looks like a grill. And the actual grill, because there is some cooling required, in the summer, especially in the summertime, takes, you have to cool the motor and cool the batteries while they're charging. So it does take some grill, but it doesn't have to be very big. And here's the Volkswagen ID4. See, they eliminated the entire grill. It's underneath. And here's the Chevy Bolt in the crossover version. There's the Mach-E. Again, there's very many models of that. They look different. They might have different wheels and so forth, but the basic look of the car is the same. Audi Q4, they really went in for a big grill. Volvo XC40. There's the Tesla Model Y. You notice their total grill is kind of down in the bottom panel. So this is on a Model 3 platform. It's just built taller and a little bit longer. Maybe just a hair wider too. All right, so now we go to large sedans. And we got a Polestar. Well, Model 3 really shouldn't be here. Because it's a medium-sized sedan, the size of a Honda Accord. BMW and another BMW i4. I want to show you one of those. They all look the same. And oh, I see what happened. So then the Porsche, the Mercedes, and Audi e-tron GT, that's the large sedan version, and the Tesla Model S. So there's the Polestar again, Model 3, the Taycan, BMW i4. They have kind of a butterfly-shaped grille. e-tron GT, that's a good-looking car. Mercedes EQS. Both got the e-tron GT twice, and there's the Model S. Okay, for pickups, I couldn't use that site because there's really only one pickup available for sale now, and that's the Rivian RT1. So it's called a Launch Edition. It's a 300-mile range. It costs $74,000. And so far in the fourth quarter last year, I believe they delivered about 50 Rivians. So there's a big, a lot of people have reserved a Rivian. So I don't know how soon you could get a Rivian. If you ordered one, it would probably be late in 2022 at best. There's a Tesla Cybertruck, which we'll look at. It's pretty weirdly shaped. There's a Ford F-150 Lightning, which has had very good reviews. And then there's a Chevrolet Hummer, which isn't really a pickup. I wouldn't call it a pickup because it has a very small bed. So most people, if they really want to pick up, that wouldn't be their choice. Okay, so here's the Rivian. And all of the trucks now are like king cab versions that have 4 doors and 2 rows of seats. And the beds are not a full-size bed, but I mean, you can still haul a 4x8 sheet, but you'll have to leave the tailgate down. Tesla Cybertruck is a stainless steel exterior, and so the body is just extremely strong. So they're using stainless steel that they actually use in SpaceX for their rockets, and it only comes in one color. If you want a different color, you have to put a wrap on it, which for a couple $1,000s, you can essentially make your car any color, and you can make it rainbow color or polka dotted or whatever you want. You can even design your own colors and have a wrap made. That'll work for all cars, not just the Cybertruck. And there's a picture from the back. It may not be quite that sharp edge because the previous picture I showed you was the model that they're now prototyping before they go into production. And this was the original model that they showed at the unveiling a couple of years ago. And it had literally sharp corners on it. And the F-150 Lightning looks just about like an F-150. Can't hardly tell the difference. And here's the Hummer. As you can see, its bed is extremely small. And I think they're not actually making them yet. Again, they just don't have a battery supply that they can make cars. Okay, so you can see there's quite a few different models to choose from. So if you go shopping, you'll have to stop in more than one place if you want to do test drives. So now let's kind of switch gears and talk about the 21st century car and car factory. So I claim it's the biggest revolution in automobile since the Ford Model T Ford, for almost all the same reasons that the Model T Ford was a revolution. So the first reason is is electrification, and so we talked all last Tuesday night about the advantages of electric vehicles. So I won't continue on that, but it is a revolution. Connectivity, feature delivery via the network, and data collection for autonomy. It's all part of connectivity. So it's really the first time cars have really been connected to the internet, although they've dabbled in it in terms of, a few cars allow the opportunity to connect to the internet, but this is connected in a way that's much greater than just using the internet. Autonomy is a revolution in progress where you get a tremendous improvement in driving safety and enjoyable trips. And there's various levels of autonomy, and even lower levels of autonomy make a big difference, but full autonomy would certainly be revolutionary. Vertical integration of manufacturing. So if you know automobile history, Ford, I believe in 1918, first opened the first part of their Rouge River plant in Detroit, or outside of Detroit. And that factory had iron ore coming in one end and cars coming out the other. So it was vertically integrated from iron ore to automobile. And that's what's going on now with electric cars. So Tesla actually owns a lithium mine. They make their own batteries. So it's one step greater than Ford in that they're also mining the lithium. And I'll talk more about that later. The speed of car design changes and production line changes. So the typical automobile manufacturer of the 20th century and the first part of the 21st century, they had new model years once a year, and they made changes in the design, usually small updates and fixes and things on once a year basis. And they retool the factory to, make the new model. And then every 3, 4, 5 years, they have a bigger change to, come up with new models. But that will be hopelessly too slow in the 21st century. So now we talk about the auto company in the 21st century. So a good automobile company in the 21st century will have online ordering with absolutely no hassle. Literally took me 10 minutes to order my car. And you can do it at home or in a showroom or from your cell phone. So there's no haggling over price either. Now you can think that, well, that's not necessarily good because, gee, I'd like to get a better deal. But it's really better if you don't have to worry about, did somebody else get a better price than me? And in the case of the 21st century automobile company, nobody gets a better price. There is only one price. So when Hertz bought 50,000 cars from Tesla, they paid the same price that you or I would pay. Vehicle delivery to your home, or you can pick it up at a service center or dealer. Most features are implemented in software. Of course, you can't get new hardware via the internet, but you certainly can get a lot of new features, and I'll demonstrate that. And these new features are delivered via the internet, so you don't have to take it to the dealer to get those new features installed. And the service for the car can be quickly scheduled via an application on your cell phone, and the service can come to you. It can be done at the parking lot where you work, can be done in your driveway, or even in your garage. Now, I've had both a service visit in my garage and one in my driveway. And real world data collection for training neural net for autonomy. So that's a combination of things that are difficult even for existing car manufacturers to implement, because it's a whole different mindset about how things are done. It's a rethinking of the whole process, from building the car, buying the car, servicing the car. So from an owner's perspective, what does this mean? Well, it's a dramatic improvement in buying experience. I don't know anyone that was, buy a car in less than an hour or two, or maybe three, depending on how many dealers you have to visit, or even if you do it online and, nail down a price, you can't pick it up in less than an hour or two. No maintenance for 2 years. And if it's any less than 2 years, it's for the benefit of the dealer only, or they've really haven't designed a car well enough. You can refill in your garage. We talked about that. Car features are added approximately monthly. The average over the last 8 months in my car is every 2 weeks, I get some new feature. And interestingly, the features are customer driven, and you can choose whether you want to update to that release or not. Now, eventually you'll want to upgrade, because some feature will come along. You'll say, hey, I really want that feature. So it's not really a real choice, because you'll always want to say, yeah, I'll do it. Longer lifetime. I mean, the drivetrains are good for 500,000 miles to 1 million miles. So the cars won't last as long as the drivetrain. Better resale value. Now that may be just because now it's hard to get an EV. So if anybody sells an EV, there's lots of willing buyers. But the resale value is holding up a lot better than ICE cars. And you have very relaxing trip due to autonomy features. And that's even before you get to full autonomy. And the actual driving is joyful. And I mentioned this on Tuesday. I mean, it's a sports car like drive even though it's just a sedan. And that's due to the performance, handling, and brakeless driving that I described last time. So there's a lot of good EVs, and those EVs that I showed you, there's a half a dozen of them that I would recommend myself. But none of them are a 21st century car, as judged from technology and features. So the Tesla is the only EV that has all of these things: improvements and new features via Wi-Fi. And I'm getting 2 updates per month. All solid state. There's no relays, there's no fuses. There's only a handful of actual physical switches in the whole car. It's got an extensive and integrated supercharging network, so you can travel nearly anywhere in the country, or in southern Canada, or you can drive to Alaska. So you can go about anywhere. And when I say integrated, it's totally integrated. You just back your car in, you plug it in, and you walk away. You don't have to tell it who you are. You don't have to get out your billfold. You don't have to have your cell phone out. You don't do anything. You just plug it in and walk away. So they have record performance for production cars. So the Tesla Model S Plaid, which is an expensive car, but it outperforms $2.5 million cars, and it costs $130,000. So we're talking about a factor of 20 cheaper for the same or for better performance. Self-driving. So the Teslas will drive on the interstate now, and that means completely you can get on the interstate. I drove one time I got on the interstate in Chicago and drove to Rockford, Illinois, and the entire interstate portion of the trip was executed by the car, and I didn't touch it. And everywhere in beta test. And I'm in that beta test, and the improvement since mid-November was almost surprising. Every problem I reported has been fixed in the latest release. So they're taking feedback seriously, and they're fixing the problems. So most of these are all edge case kind of things. Energy efficiency up to about 4 miles per kilowatt hour. Okay, so now I've stated all this, and I've said it's the only car. But now let's look at the real data, and you can tell me whether you believe what I just said. All right, so I mentioned about fuses and relays. So here's the ID4, Tesla Model Y, and the Ford Mach-E. So you can see the Mach-E and ID4, they're from a different century. They have 70 to almost 90 fuses, and they're in 3 fuse blocks. So there's probably one, under the dashboard on the driver's side. There's probably 2 under the hood somewhere. So not only do you have to figure out what fuse blew, you have to figure out which block you need to look in to find it. And I've replaced a few fuses in my life in cars, and it's never fun. And relays, 22 relays in the Mach-E. So relays are problem-prone things. They're physical. They have electrical contacts that arc and get dirty and so forth. So they're just problems waiting to happen. And the Tesla has 0 of all of these because they use solid state sensors to shut off power to any circuit that is drawing too much power. And they use solid state switches instead of relays. And of course, they don't need any fuse blocks. All right, so let's just look at some design manufacturing things. So Sandy Munro is a car expert. He's essentially an engineer that now owns a company that analyzes car design and car construction and car costs and so forth. So every new car that comes out, he buys it. His company buys it. They tear it apart piece by piece. They analyze how much it costs to manufacture, because they know how much it costs, to add a screw to the design and various fasteners and how many spot welds it has. So anyway, they know exactly how much it costs to do these things. So they estimate the cost of producing the car. They analyze its design to see, and then they write this huge report to recommend to the manufacturer things that they could use to make it more reliable, have higher quality, be easier to manufacture, have fewer parts. And so the best part is no part. So they're really fans of getting rid of parts. So if you just look at, compare a Mach-E to a Model Y, almost equivalent cars on the outside, and look at the thermal hoses. So there's a lot of cooling that has to take place. You have to cool the battery while it's charging. You have to cool the inverter. You have to cool the electric motor. And so there's a cooling system with water, just like in a normal car. And the length of the hoses in the Mach-E, there are 3 times more hoses than a Model Y. Same kind of car. Part count, there's 3 times as many pieces in the thermal hose arrangement. And there's over twice the weight of the fluid. and weight is a big issue in electric cars. So here's another example. The Chevrolet Bolt versus the Tesla Model Y. So on the left is the high power cable going from the battery to the distribution system in the car. There's a single cable, 2 connectors. There's arguably at least 4, and if you look at it, there's really about 7 cables. Some of them are fastened together, so it doesn't look like so many. And just count the connectors. So there's 11 connectors versus 2 connectors. So this is a quality problem too. So not only is it weight, not only is it a lot of copper that you didn't need to put in your car, there's lots of connectors. And as you all know, being computer experts, connectors are just a problem waiting to happen. All right. Well, Sandy has taken apart all of the main cars, and he's done an ID4, a Chevy Bolt, all the Teslas, a Mach-E. So he has pretty good idea of how these cars are built and how they were manufactured. And so there's an interview where someone asked him what kind of lead Tesla has in various areas of design and production. And here was his answer. Motors, 3 to 4 years. They have the most efficient motor of any car maker. The battery, he thinks, is a 6 to 7 year lead. And it's kind of a combination of how the battery is managed. It's not just building the batteries, but it's how they're cooled and how the batteries are managed to take out bad cells when they go bad, how tolerant it is of overheating of parts of the batteries and so forth. Anyway, 6 to 7 years. The full self-driving chip is a total duplex computer, an AI computer, a neural net, a huge neural net. And it operates at like 20 times faster than any NVIDIA chip, which is what they used in their first neural net computer. And so it's a 10-year lead. Thermal management, this has to do with, how you route all of that water coolant through the car. There's a thing called an octavalve in a Model Y that is a single valve. It's kind of 8 valves in one that is like one unit, and it does all of the thermal management to get the chilled water where it needs to go. High voltage wiring, 4 years. I showed you an example of that. It's going to take Chevrolet a while to figure out how to get rid of all those cables. Giga casting. Well, this is pretty interesting. So there's a battery carrier in the center of the car, right? Then there's a kind of a front end chassis and a rear end chassis. There's a total of, in a Tesla Model Y, there's a total of like 209 pieces to that front and rear part of the car. So Tesla had what they call a gigapress built by a company in Italy that make the largest metal presses in the world. And it's not just a press. It's really poured metal. And so they have built the entire back end now as a single piece. So the old one had to be bolted and spot welded together. Now it's one piece, comes out of this gigapress, and it's ready to put in the car. And likewise for the front end. So they just took 209 parts out of the car and replaced them with 2. With the requisite amount of time it takes you to build those 209 parts individually, and then assemble them and spot weld them together. So the efficiency of production when you do something like that is just astounding, and I'll talk about the numbers in a little while. Software, 5 years. That's just general software that's controlling the car and so forth. It's not talking about the software for self-driving. So let me say, okay, this guy is crazy. You know, he's just a Tesla fan, and those numbers are off by a factor of 2. Well, they still have at least a 5-year lead in 2 key areas, and they have a several lead year everywhere else. All right, so let's talk about efficiency. All right, so here's 4 cars: Tesla Model Y, Ford Mach-E, VW ID4, and the Audi Q4 e-tron. So the efficiency is the center column, miles per gallon E. So that's the energy in gallon of gas, how far will it take you as electricity. So the Model Y is 125. So it's a 25% higher efficiency than a Ford Mach-E. And a Ford Mach-E is pretty high in the EV industry. Well, what happens? In order to get range, you have to have a bigger battery. So the Audi, they're not even competitive here. So they have, you know, almost a 25% larger battery, and they get a 33% less mileage from a 25% larger battery. So I would not recommend an e-tron, because I mean, they're just not even in the ballpark. This has to do with the efficiency of the inverter, has to do with the efficiency of the electric motor, and it has to do with battery management. So now let's look at it more generally. So that was just picked 4, but I didn't pick just the 4 that were the worst. I just picked 4 that I could find the numbers on. So here are them plotting vehicle weight along the bottom. And so the bigger the car, the lower the efficiency. That makes sense. You know, pickup trucks get 16 miles to the gallon, right? So you expect that. And then, so this is in miles per kilowatt hour. And it's the EPA range. So it's not determined by the manufacturer, it's determined by the EPA. So you can see there's definitely 2 classes here. One is Tesla, and it's about 2 miles per kilowatt hour above the line of everybody else. So remember, the Mach-E was pretty efficient. Well, you can see how far away it is from a Model 3. It's a huge difference. So, and so, you know, if you pick a car on this line, you're picking a car kind of in all the rest. You definitely shouldn't pick the BMW here. I mean, it's just way off the line. It's the lightest car here, and yet it's not even close to even the line of the regular cars. So as the cars get bigger and bigger, they move down. So a Neo is really a full-size car, and the Rivian pickup is you know, clear over here, as you would expect, because it is a truck. Okay, so let's talk about a little more about design and manufacturing. So Herbert Diess, who's the Volkswagen CEO, actually said that VW's new ID4 factory, they built a brand new factory just for the ID4, requires 30 hours for them to build a car. The Tesla factory will build a car in 10 hours. So a third of the time required to build a car. Well, right now, that improvement in how long it takes to build a car results in Tesla having the highest margin, gross margin on the car manufacturers of all of the EV makers. And they're keeping their price where it's at because they can't build enough of them. And they're using that revenue and the high level of profits they have to plow into building new factories, two of which they just are finishing now in Berlin and Texas. So you might have thought that the legacy automakers would be really good at making cars. But here's the new upstart that can do it 3 times faster. And I'll talk more about why that is. Also note that manufacturing a new designs is hard, even for the big automakers. So Tesla itself has had problems with their Model S and X, and many problems over time, especially with the early Model S's and with the Falcon Wing doors on the Model X. So even they aren't perfect. I'm not saying they are. Ford Mustang Mach-E has had recalls for lack of adhesive on the windshield and sunroof. They actually made fun of Tesla when they had a little problem with the adhesive on their roof. And then they've also had electronics problems that resulted in the people not being able to get in and drive their car. So Chevy Bolt has had a major recall on battery products that we discussed last time and causing spontaneous fires. And all manufacturers have had various software problems. There is a difference though. When the Mach-E was having trouble with their electronics, you had to take the Mach-E into the dealer to get new software installed. When Tesla has a software problem, none of which has ever caused you not to be able to drive your car, they deliver to you while it's sitting in your garage over the internet. So there's even a difference about the speed of getting software problems fixed. So software expertise is not one of the legacy automakers' strong suits, but that's clearly become a key requirement in the cars of the 21st century. All right, so, but the lead that Tesla has is not the only problem for the legacy automakers. So as we mentioned earlier, and as you all know, they tend to change their cars and production lines 1 time per model year. Tesla has a whole different approach. They use agile software design, and I don't know how familiar everybody is with agile software design and Scrum models and so forth, but you know, it's a way to very rapidly develop, test, and deliver software. And they decided to apply that to factories and building hardware. And as a result, they are continuously making changes to both their cars and their production lines. They are making an average of 13 changes in their cars per week. So I mentioned the octavalve before. Sandy Munro took a car apart in May, or in April, and then he took another one apart in early July, 3 months, and they had made 13 changes just in that one valve. And he said he has never seen that kind of change rate of any car anywhere ever before. So if that's not a revolution, I don't know what it is. They changed their production line 27 times a week. They have 12 spots in their production line where you can essentially, okay, and then there are gates at each production station. And the car and all of the parts that are going to be added to the car at that station have passed tests that are totally automated and analyzed by artificial intelligence to qualify to begin that next step. Well, there's a split there, and they can take a car and its parts off to a special area. So if anybody in the factory doesn't make any difference who, anybody in the factory comes up with an idea. They put the idea on a board. If people in the factory like that idea, think it's a good idea, they volunteer to go work with that guy and try it out. So they go on this, separate space. They try out their idea. It can be an idea to save a step, to change a part so it's easier to put in, that something that improves the quality. It can be an idea about literally anything. So when they've got it figured out, I mean, it might take them 10 times as long as, so the cars that are moving through the production line. But when they finally have done what they wanted to do, the car still has to pass the tests to get to the next station, but they merge it right back in the line. So they'll know by the time the car is complete, they'll know that it all worked, and it won't even be allowed back in the line unless it passed the test. So that's how they can manage this process. And interestingly, VW has a goal to reduce the production time from 30 hours to Tesla's 10 by 2026. That's the goal that they set. Can you imagine where Tesla might be by 2026? By the time they catch up, Tesla may be even farther ahead. It's quite likely. So let's look at kind of another way they're doing this. So here's a picture that I took from someone else. But basically at the top row here is the way the current manufacturers operate. So they have their car factory here at the end. And so somebody's mining the lithium, they're sending the lithium to battery manufacturers, they're making the batteries, and those battery suppliers are supplying all of the automakers. And they're CATL and Panasonic, they're big name battery makers, Sanyo, and they provide all the automakers their batteries. So Tesla looked at this whole process, but given that batteries is the key component in cars, they looked at the entire process from beginning to end. What do the miners do to process the ore they get out to extract the lithium? What form is the lithium in when we get it from the miners? What do we have to do to get it in a form we can put it in our batteries? And they looked at that end-to-end process, and they discovered that the way the miners were extracting the lithium from the ore and putting it in a different form that they were shipping cost them extra steps because they had to use an acid bath to essentially get the lithium that they wanted for their batteries. And that was very dirty environmentally because you have these acid baths. And it turns out there's another process you could use if you didn't do that first process at the mine that would save those intermediate steps and prevent having to use this nasty bath. It would save like 30% of the floor space they were using for making their batteries. And of course, those steps also take time. So they went to their lithium supplier and asked them, don't process the lithium. Send it to us, after it comes out of your crusher or wherever it is in the mine. And so they eliminated all those steps. Not only that, they went out and bought their own lithium mine. So now they've gone one step further than Ford did in the early 1900s. So it's not the ore coming in the front end of the factory. The factory extends out to the mine. I mean, it's just mind-blowing. Also, as I mentioned on Tuesday, there's 3 different battery chemistries they're using depending on the application of the batteries. Of course, they're making batteries for, power companies and solar arrays and so forth that are different than their cars. So there's at least 2 different chemistries they're using in the car batteries, and they have a chemistry they're using for batteries that aren't going into cars. So anyway, and Panasonic is partnering with them on the batteries that they're making currently, but all the new factories they're building, the one in China is building its own batteries. The one in Berlin is going to manufacture their own batteries, and the one in Austin, Texas is manufacturing their own batteries. So Tesla will own the process from the mine to the car. All right, so let's go back to the owner a little bit. So what's all this mean to the owner? Well, the Tesla average owner satisfaction, according to CR, Consumer Reports, is like 88. Next highest brand is 79. And Audi and BMWs, very high end, very expensive cars, are 70. So why is that? Well, here's a set of things my car will do. And, some of them your car may do, but most of them I bet not. So the car locks itself automatically. You don't have to remember to press the button. You don't have to get a fob out of your pocket. You just walk up to the car and get in. The car turns itself on and off automatically. There's no button. Why do you need a button? Just put it in gear and go. And they're soon going to have it put it in gear itself, because it's going to figure out that if you're pulled into the garage front end first, that you need to go in reverse to start. So they'll put it in reverse. You may have to step on the brake or something to activate it. The car automatically opens and closes my garage door. So this is a feature that I got after I bought the car. It's it's not a huge deal, but any car could do this, but I don't think any car does that yet except the Tesla. I mean, they have GPS, they know where they're at, they know if they're close to your garage, and so I never have to remember, or I never get 2 miles away from home and say, oh my gosh, should I close the garage door and have to drive back to look? So it uses AI to operate rain sensing wipers. So it's actually looking through your windshield and deciding by the number of drops on the windshield when it needs to swipe the wipers. I have to admit, this is not perfect yet. In a very, very fine fall mist in the north, in Illinois, it sometimes doesn't wipe as often as I want it to. Of course, you can still press the button to do it. It automatically heats and cools the cabin at a specified time. It looks on your calendar, and if you have where you're going on your calendar, it'll automatically set the navigation destination to go there. Lots of things are controlled by voice. And I mentioned last time that I just, say where I want to go, and it identifies the places I might mean. If I say, a Holiday Inn, it shows me all the Holiday Inns in the city that I mentioned. I've never had, in 3.5 years, I've never had to type a destination. Records video all around the car when it's parked, and it saves a video if a threat is detected. A lot of people that were damaging cars have been caught by the police with these kinds of videos. It fully drives itself on limited access roads. Still requires you to monitor it, of course. I can summon the car from the parking lot to come pick me up. And so that's not something you use very often. It's not a great feature, but it's very interesting. And in some cases, it can be extremely beneficial. So my granddaughter and I and wife were out at a restaurant, and it was a rainy day. It was lightly raining when we went in. The whole time we were there for an hour, it was raining cats and dogs. When we came out, there was a 3-inch lake between us and the car, and it was blocking all of the lanes, in the parking lot. And I just had regular shoes on. It would have gone over the top of the shoes. So I stood under the awning, and I told my car to come pick me up, and it drove up, and I got in the car without even using an umbrella. So there are cases where it's really nice. Entertainment while driving. Well, so it doesn't have satellite radio. but it has FM radio, it has streaming music, it has podcasts and Spotify and TuneIn, and so you can get music. All you have to do is, say what you want to hear, and it'll find where it's at and play it for you. So a lot of the features were added since I got the car. There are probably 25 or 30 significant features that I have now that I didn't have when I drove it off the car lot when I bought it. So there was a 3% efficiency increase. The charging rate was increased from 100 kilowatt hours to 150 kilowatt hours and kilowatts, and now it's 250 kilowatts. And so that drives the time of 15 to 20 minutes that I talked about when you make a long trip. It automatically does mirror folding, unfolding in your garage. You can set it not to do it if you have plenty of room in your garage, and in a parking lot. So it always folds the mirror in a parking lot just to keep people from running into it. I mentioned the garage door, dog mode. You can leave your dog in the car and go shopping, and it'll keep the car at a nice temperature for the dog. It also puts a big notice on the screen that has a picture of a dog wagging its tail, and it says, "I'm fine. It's 70 degrees in here. It's beautiful." They also have camp mode. That by the way is the feature that I got after I bought the car, and it's the same kind of thing. It's just like dog mode, except it's for humans if you want to sleep in your car overnight. You can schedule a time to leave, and the car will make sure that it's fully charged and the cabin is comfortable before you get in. It does automatic routing to the next appointment. I mentioned that. It automatically captures the last minute of video if you sound your horn or if you crash. The security mode, so I can see the video around my car remotely from my phone, and of course it's capturing it and recording it if anybody really threatens the car. And I mentioned summon and navigate on autopilot and beta full self-driving in the city. Joe mode. Here's an example where a customer suggested to Tesla that the gongs that Tesla was sounding as a notification in the car were a little bit too loud, and so it was waking his sleeping children up in the back seat. So they named the feature after Joe, who made the suggestion and distributed it to all their cars. So I have Joe mode turned on in my car because I don't even like the louder bong. Entertainment. While you're parked, you can play games, chess, backgammon. You have Hulu, Netflix, YouTube, a bunch of other things you can do while you're parked. And just recently, they finally released routing using waypoints. So used to be, it would plot your a route to your destination. But if you wanted to, go off the interstate and cut across country somewhere, it wouldn't do that until you, drove that way far enough for it to replot the route. But now you can set it up in advance, which is kind of nice because sometimes you're going to go to a different supercharger than it thinks you're going to if you cut across country, and you really want to know before you make that cutoff, can I make that supercharger? And so if the route actually is the route you're actually going to take, you'll know. So it's actually quite useful. Okay, just an example of technology. If you look up at the top here, this is the map. Right now there's a panel over the map because I'm adjusting the air conditioning system. But this, notice the map is a satellite map. It's kind of nice because you can see, can I get into that parking lot from this street, for example. But I did this to show how the air conditioning system is controlled. So the air is shown coming out of the vents here, And you can see my wife and I have a different view of where the air conditioner should blow. My wife likes it to hit her right in the chest. I like it up over my shoulder. So you can split this apart and like I did, or put it together. You can move them up and down, and it's all done with your fingertip. No louvers, no plastic vents that get dusty. It all comes out of the slot in the front of the car. Okay, some sample quality and hardware items. So the Model 3 has the most comfortable seats of any car that I have ever driven. My wife would not agree with that, but she thinks they're comfortable. But she, for example, somehow the driver's seat is a little different than the seat that she has, even though they're both 6-way power seats, because she doesn't mind sitting in her seat, but she doesn't like to sit in the driver's seat as well. It's the best car sound system I have ever heard. It's better than my own 5.1 home stereo system. In fact, I'll tell you a story. Kai, one of the persons that is on the calls tonight, is my grandson. And so I was staying with him a couple of weeks in October, and we were watching a movie while we were waiting for the bus to pick him up, which is like a half mile from his house. So I drove him up there. And while we were waiting, we were watching a movie on Netflix. And that evening, he said, "Hey, can we go watch the rest of the movie?" Because, of course, didn't watch the whole movie. "Can we watch the rest of the movie out in the car?" And I said, "Sure." And when I asked him about it after we got out in the car, I said, "Gee, I was a little surprised." He says, "Well, you know what? The seat's more comfortable than what we have, the couch we have at home, and the sound is awesome. And you're close enough to the screen in the front seat that it's like watching a widescreen TV." So not only did we finish watching the movie that night, for the next 2 nights, we watched the other 2 installments of that 6-hour-long movie, or whatever it was, a 4-hour-long movie, I guess. So we watched it in the garage. And of course, we were comfortable because it kept us warm, even though it was a little chilly. So the roof is all glass. You might think, well, that doesn't sound good. Well, it turns out it is good. It's just wonderful to be able to look up at the sky. It's tinted fairly heavily, so you're not blinded when the sun comes through it. But it blocks 99% of the heat from the sun rays. So it's actually cooler in the car than it would be if it had a metal roof. And it's stronger than a metal roof. You can stack 5 Model 3s on top of my Tesla without breaking the roof. In fact, there's a video on YouTube that somebody following a Tesla Model 3 was driving down this road, and there's this huge tree that got blown over just as the Tesla went by. And it landed right across the passenger and driver seats in the Tesla. And it did break the glass, but it didn't like shatter it, but it broke it. But the combination of the glass and the steel edges of the roof, the driver was uninjured. And I mean, this was a big tree. It was like 2.5 feet across. Large display. The 15-inch screen has room for information map and now a self-driving visualization of the environment. So it shows every person, every dog, every car, every trash can, every traffic cone, every stoplight and stop sign that you encounter is shown on the visualization. The ride is a bit harsh. So it's kind of a trade-off with handling and the weight of a 4,000-pound car. But, and the recommendation I would make if you're getting an electric car is to get the smallest wheels that you can get on it. So if it comes with 18-inch wheels, get the 18-inch wheels. Don't go up to the 20-inch wheels because you'll lose a little bit of the cushioning of the wheels. Besides, the 18-inch wheels are more efficient, especially in a Tesla, because they have an aero hubcap that's specially designed that gives you like a 3% performance improvement on the highway. And there's a huge amount of storage for a mid-size sedan. So I replaced a Lexus RX 450 hybrid with this Model 3, and I can get on a long trip when I'm going to a different place with lots of luggage and boxes of stuff. I could get all but one book box of what I used to haul in the Lexus. Of course, it has the frunk. It has a deep kind of a pit in the back of the car that you open up, and it's like 1.5 feet by 2 feet by 1 foot deep. So there's a lot of space. And that's common for electric cars because there's no gas tank, so you got the space from that. And there's no big engine, so you got the space from that. So on the other hand, Consumer Reports claims the quality is relatively low, but they don't really share how they weight the various kinds of problems. So I have a clear weighting of things that are important to me and things that are not important to me. So little, cosmetic kinds of things are not a big issue for me, even though my car doesn't have any panel gap problems or anything like that. I don't score that very highly. So my car did have one, arguably two manufacturing defects. The turn signal switch didn't work correctly. I mean, it worked, but you couldn't get it to just flash 3 times to change lanes. And in kind of car makers now are delivering cars with 0 faults. So the fact that Tesla had one, would make it score low for quality. But it gives you so much more in every other way that people that own Teslas just overlook it. And but CR at the same time shows that Teslas do have high owner satisfaction. So owners are not using the same criteria that CR does. And I could also mention that Consumer Reports tests full self-driving software, and they don't like the Tesla software. But again, it's how they do the scoring. So I reverse engineered their scores, because they tell you individual scores and then they tell you the summary score. So I reverse engineered the scoring weights. And then I said, assume that I had a perfect full self-driving system in my car. Would it score high? And it didn't. It still got beat by the GM product. So it didn't have anything to do with how well the car drives or how well it drives itself. It had to do with, they didn't like the fact that you could fool the car into thinking that you had your hands on the wheel. So, and they just put such a high score on that no matter how well the car behaved, there's no way it could win this evaluation. All right, that's just one slide on safety. So I mentioned that EVs in general should be safer, but that actually hasn't been borne out, because some EVs don't get a 5-star safety rating. And the Tesla models S3, X, and Y are the top 4 safest cars ever tested by the National Highway Traffic Safety Administration. And this graph was shown before the Model Y was tested, but you can see the Model 3 is the safest car in terms of probability of injury of by far. I mean, the next non-Tesla is twice as likely, and these are low probabilities, but it's twice as likely to be injured in a serious crash. And, you know, there's hundreds of cars, and this just plots the first 50. And, you know, by the time you get out to the 50th one here, we're talking about 3 or 4 times worse. So not only does the Highway Transportation Safety Administration think they're safe, but the Model 3 and Y just won the Insurance Institute of Highway Safety Top Safety Pick Plus. I think it was last year. So it's another independent evaluation. So who are the competition? Well, China is the competition. China has more EV companies than any other country by far. They have about 20 new startup EV companies, some of which that are producing cars. And in addition, their legacy automakers, a big one, BYD is one of the biggest automakers in the world. And they started in 2003 with a small electric car. So they've been in the business a long time. So this is in order of the top 10 sales in 21. It's through third quarter of 21. So 500,000 SAIC. They have this little bitty car that's only costs $6,000. It's not really even legal in the United States, so it's not a car that you would want, but they make lots of them. And so you can see all of these cars, and SAIC is also owned 33% by General Motors. So sometimes General Motors includes the sale of SAIC cars, but that's like saying I own Tesla stock, so I'm manufacturing, you know, whatever percent of the stock I have times the million cars that they produce. So it's just, it has nothing to do with General Motors. You know, they happen to own the stock in the company. So that some of them have kind of weird names, and even the cars are weird. Or a black cat. Well, maybe it's the translation that's the problem. NIO, interestingly enough, started in 2014, and they have 5 models and pretty cool looking cars too. And they have sales in 6 countries. And I think they're going to start selling cars in the United States in this year. And they're kind of modeled after Tesla. They can remove the battery pack from the bottom of the car just like Tesla can. Although Tesla has eliminated that now for the Model Y because the battery pack is part of the chassis of the car, so you can't really remove it. Okay, so now let's look at the goals of automakers. So here's the stated goals for 2030 for the percentage of their car production that will be EVs or hybrids. So if you said battery EVs, most of these bars would be cut in half. So Tesla, of course, is all battery EVs, so they're 100. And Honda, there's lots of non-EVs in there that are hybrids. But you can see that Tesla is the only one that plans, and it's because they're an EV maker, but they're the only ones that are planning to have it all EV by 2030. And if the growth in EV sales continues the way it has in Norway and Europe and UK and in China, that's going to be a problem. They're not going to be able to produce enough EVs. So you say, well, what is their goal for 2030 in terms of how many cars they'll produce? Well, here it is. Tesla plans to produce 20 million cars. Now, they only produced 1 million cars last year, so you might say, nah, they can't do that. I would say they might be able to do it. So they have been doubling their production since 2012, every 18 months. And they are going to double again this year, nearly double. They were 93%. This 2021 over 2020, they increased 93%. So that's less than a year and a half. And they have 2 new factories coming online. The one in Austin, Texas will be the largest automobile factory in the world by about 4 times. So when they get that up to full capacity, which will probably take them a year and a half, the Chinese factory they were producing cars in under a year from a bare field. And now after the factory was in operation for 18 months, and they're adding on to the factory continuously, and they're still increasing production. So they know how to do this. And notice that their revenue and their gross margins are very high. So they're generating cash to pay for these billion-dollar factories. In fact, the factory in Austin is expected to cost $4 billion by the time it's completed. And all these other manufacturers, their car sales have been going down for the last 5 years. And not just because of COVID and, the semiconductor shortage. They were going down before that. And in fact, Toyota just exceeded General Motors for the first time in the fourth quarter of 2021 in sales in the US. So General Motors is still dropping. And if you think about it, they have to keep selling the ICE cars because that's their profit makers. They're not making a big profit on their electric cars. Or maybe they may not be making any profit on their electric cars. So if they can't sell ICE cars, they won't have any revenue to or profits to put into building new factories. I won't go off on that tangent. I will say one more thing. Every U.S. automaker is seriously in debt. There's a scale that's used to evaluate how much debt a company has. All of the legacy manufacturers in the United States are in the danger zone, meaning their revenues don't have to drop very much until they can't service their debt. So some of them, I will go out on a limb and say they will not survive this revolution. Okay, a couple of links if you're interested in looking at these cars and what's available. The PlugStar is really nice. Also, APS, which is Arizona Power Systems, it's the electric company in Arizona. They've built a website that is for buying EV or for finding EVs. So click that link and you'll see the interface they have. It's pretty nice too. But PlugStar is really cool. So because you put in your zip code, so they only show you EVs you can actually buy where you're at. Okay, I think that does it. So same advice as last time. Test drive one of these before you, if you're going to buy a new car. And be aware that EVs take some retraining. And based on what I just told you tonight, EV design really matters. So you don't want to buy an e-tron because, they're not even close to having the technology right. And again, there's the link if you want to buy a Tesla.